Video D3: Production and Cost in the Long Run. The full economic cost of production results from the economic cost of all of the inputs used in the production of a good or service. For example, if we have only a single input, or equivalently, all other costs are what we call sunk and have already been or previously paid for, then the cost of production is simply based on the price of that single input. Returning to our example, quantity produced equals 30 times the square root of L. If the wage rate for that labor is equal to 100, then we can look at the cost of production for each use of labor, resulting in several different levels of production. Let's make a table to illustrate this, starting with labor at levels of, say, 1, 0, 1, 4, and 9 for convenience. That would lead to output of 0, 30. 2 times 30 would be 60. 3 times 30 would be 90. If we add in now the cost of that production, we have 0 cost when we've used 0 labor. But now if we use 1 unit of labor, we have a total cost of 100. 4 units of labor will be a total cost of 400. 9 units of labor, a total cost of 900. Note that our results here show diminishing returns, just as we showed directly from the production function previously. Our total costs, if we look at the third column, are increasing as we increase in output. So each additional unit costs more and more to produce. This is a summary of production in the short run with just a single input. But if we want to look at the long run, we will typically look at 2 or more inputs to production. In the long run, all inputs can be used in any combination. Production decisions involve not only consideration of how much to produce, but also of how to best combine inputs in order to minimize the total cost at each level of production. Consider our convenience store again. From experience, they have found that they get the same number of customers served in a period of time, the same customer throughput, the same output queue, with 2 workers and 4 checkout stations, or 3 workers and 2 checkout stations. We can summarize this by looking at an option 1 or an option 2 for production. Option 1 has labor equal to 2 and capital equal to 4. Option 2 has labor equal to 3 and capital equal to 2. We can add now in each case that we have a wage rate equal to 100. We'll use what we had before. And now let's have the cost of capital, and I'll use R to indicate the cost of capital. Let that be $60 per day for each checkout station. Again, on option 2, we'll have the same labor cost per unit and the same cost of capital per unit. So what this ends up meaning then is that we have a total cost in option 1 equal to the amount of labor we're using times the cost of that labor plus the amount of capital that we're using times the cost of that capital, or the total cost is equal to 200 plus 240, or it's equal to 440 in this case. Total cost 2 we can find in exactly the same way. 3 units of labor times $100 per unit of labor. Capital will be 2 times 60. So that's going to lead us to 300 plus 120, or we're going to have 420 for our total cost. So the way in which we minimize cost, or the lowest possible cost, will be to choose 3 units of labor and only 2 checkout stations here. At each particular level of production, there will be a combination of inputs that would be used, which would lead to a particular lowest possible cost in each case. Putting together the lowest cost input choice at each production level gives a firm's long-run total cost curve. It's useful to think about the resulting long-run average costs that we would achieve at each of these levels of output by looking at a graph of long-run average cost at different levels of output. So I want to look at dollars per unit and just the average of the long-run average cost. If it happens to be constant, if it does not change at different levels of output for the average cost, then we would say that this has constant returns to scale. And that's when we look at a constant long-run average cost. In contrast to constant returns to scale, we might observe that as a firm adds capacity and gets larger and larger, what we might find is that costs come down per unit when we look at the long-run average costs, that by operating at scale, we get what we call economies of scale or increasing returns to scale. Finally, it may turn out that in a particular industry that there is little opportunity to increase scale in the long run, even after adjusting to all inputs to that increased size of the output, and the result may be that we have increasing costs in the long run. In this case, we would call this decreasing returns to scale. We can label this constant returns to scale, CRS, increasing returns to scale, IRS, or decreasing returns to scale, DRS.